Tell me that. Okay. Going for the right. I got it. All right. So, boom. So, welcome Programming Club. Good to see a bunch of people here. If you have not yet, please try going to dsuprog.club to sign in. We will add the caveat that things might potentially be broken. So if it doesn't work, that's why, but it might. It's the first week. We got some things to shake out. But once you get to dsuprog.club, go to the meetings page, click View Meeting button there. Then you need to sign in with your DSU credentials, and then hopefully you're able to see this slide on your screen. But yeah, by signing in, that allows us to take attendance and note that you guys showed up to this meeting. Is it working? Everyone doing all right? Getting into work? Thumbs up? Sweet. All right. So, a little club introduction. This is Programming Club. As you guys know, we're meeting every Wednesday at 6 p.m. right here in this location. Once East Hall reopens, we'll be in East Hall 100 in that big auditorium. There'll be a lot more seats for all y'all. So our officers, this is Nick Sanderson here in the pineapple shirt. You can stand up properly. And Aaron Ingalls here. And then I am Nick Handberg. So our contact information can be found at dsuprog.club on the About page. There's like our Slack, our email, our GitHub. So feel free to reach out to any of us for any coding questions or anything that you'd like to know. Also, in terms of questions, once you have signed in, you'll see a little text box below that says, like, if you have any questions, you can fill out your questions there, and those will be submitted anonymously. Nick and Aaron will be watching those here, and they can ask me the question. If you are too shy to raise your hand in front of everyone and ask the question, that's the way that you can still get your question answered. Also, for those of you new students here, welcome. First of all, welcome to all freshmen. If you've not joined the Colonel Popper Slack, please do so. This is where all the club announcements will be made. So it's a very useful platform to reach out to other DSU students, faculty, and alumni as well. So there's the link there. You need to use your DSU email in order to create an account. If you use your personal like Gmail or something, it won't allow you to do that. Just to verify that everyone on that Slack is affiliated with DSU. So once you join that workspace, you can join any channel you want. There's a bunch of different channels on there. Marketplace, you can sell your graphics cards to each other. Ultimate Frisbee Club. The one that's important to this club is the Programming Club channel. So join that one, and that will give you all the club announcements that come through, as well as weekly reminders of that we're meeting, where we're meeting, and what we're talking about, and who's presenting. So, highly encouraged to join that. Also, we'd like to announce DigiKey, programming competition that's hosted by DigiKey in Thief River Falls, Minnesota. So we'll be forming 2 teams of 4. Juniors and seniors will take priority. So if you're interested, you can sign up by scanning the QR code. I think you can also click the QR code because Aaron was fancy and wanted to make the QR code hyperlinked. Go in there and there'll be a Microsoft form to fill out showing your interest. All right, now to what you guys all showed up here for, version control with Git. So we'll start off with a cheesy pun and getting good. Git is good, and it's important to get good at Git. And here's your chance to insert all other Git puns. and make the world cringe along with me, because I'm good at being cringe. What is version control? Basically, it allows you to track your changes, save your progress when you're working on things. Kind of like if you've noticed, like on a Google Doc, there has like that version history. You can go back and see like different changes. But this is a much better, much more reliable way of tracking your progress and saving it. And it allows you to return to previous states of code. So if you're, if anyone, I'm sure we can all agree that we've been working on some type of code, tried to go on to the next step, and completely blew up everything with our code, and nothing works anymore. Git and just version control in general is really powerful in that you can go back to that previous state where things were working and try again. You aren't, completely SOL per se if, with version control. So Git is an example of version control, just kind of like C is an example of programming language, but Git is by far the most popular and utilized version control system out there in the world. So why is Git important? It's essential in the workplace. I got the chance to intern at Omnitech this past summer, and we used Git a lot. I didn't really know much of Git going into the summer. I learned a lot over the summer though, and it's really, really important, especially when you have like multiple people collaborating on source code amongst teammates. Not only does it track your progress, but it allows you to figure out like, okay, who put in changes, where those changes made, and it allows you to get those changes in a good and effective way. An ineffective way, for an example, is last year I did an assignment in one of my spring classes, and we were working on this big coding project with a team of 4. And for every change that we made, we would copy it all and post it and paste it into a Discord message in a Discord server. This code was about 1,000 lines long. It was very painful updating changes that way. Whereas if we had used Git, it would have been much more easy to get those changes without having to copy and paste everything and then go through and read those 1,000 lines and figure out where did things change. Like I said earlier, it provides insurance, so you can go back to previous working state, not precious, although it could be precious, if your code is somehow broken. And like I said, there's definitely a learning curve with Git. I definitely experienced that. But just the more time you spend with it, the more you'll grow comfortable with it, just like every other thing in coding and programming and just computers and life in general. And then I put this command line better than GUI. Aaron would disagree. They both have their pros and cons. Using like buttons in Visual Studio Code are really nice when you're like first beginning and you don't know, like, you're learning the terminology and how things work. Those buttons are nice, but learning to do it the command line way is the best, because you never know like what kind of environment you'll be working on, in the workforce or something. If you're in like a shell only, like for those of you who are taking a class with Tom, when you remote SSH in to his server, there's no Visual Studio app you can run there, and so you would need to know the command line arguments there. That, and it's important to know like how it's doing what it's doing. If you were just told in CSC 150 to just tell the computers print hello world instead of learning how to print hello world the right way in C, like the computer still does what you wanted it to do, but you don't know how it did it. And so that's why, it's important to kind of learn those command line arguments as you grow comfortable with it, because that's really the important foundation. So some quick terminology. There's a lot of terms in Git that can all get jumbled together and confusing. But some of the main ones to start off with is a repository. So this is like a project folder very similar to like a folder in your file explorer on Windows that has all of your files in it. A repository is just that thing, sort of thing. A commit is like a snapshot. It stores the changes that you have made. So with each change that you make, you can make a commit. We'll talk about that a little bit more down the slides. But for now, it's just a snapshot that stores your changes. And that's what you can use to revert back to previous changes if your code had broken. And then a branch is a pointer to a commit. Default branch is usually master or main. They're interchangeable, but both kind of have the same concept. So when it comes to working in Git, there's 3 states of your code and your files. There's the modified state, the staged state, and the committed state. And so yeah, as you can read there, modified is like whenever your file is changed, like you're in your editor and you just hit save and you added 5 lines to your code. Your file has now been modified from the previous version. And then once you have that file modified, you want to stage it to add it to the commit. And so an analogy for this would be like if you're working on your code on your local computer and you're about to submit it to D2L and you're going to attach it, and you can choose like which files do I want to attach. That's kind of what the staging is. It's like you're setting up which files you want to include to make that commit, and then that commit is like pushing submit on your D2L assignment. It publishes your changes and puts that snapshot into your repository. So, demo time. If you don't have Git installed on your system, we can install that quick. If you're running on Mac, you can run brew install Git. For Linux, apt install Git. Or for Windows, you can go to git-sem.com, and then you can download for Windows there. And then there'll be, once you like get the initial installer up and loading, there'll be like 1,000 different options to click through. Just stick with all the defaults and just hit next 20 times until it's off and running. Why do I wait for them to install? Do I just keep going? What did you intend when you did that?
Maybe wait for people to install.
Any questions so far while people get set up? If anyone is getting set up, if you want. If you're ready for me to keep going, I can as well. Thumbs up if we're ready to go on. Okay.
Do we use a credential helper?
Let me see your screen. Do whatever the default was, whatever was previously selected. Yeah, just stick with all the defaults. There's a lot of weird customizations. So while we get that set up, all right. So for those of you that are still installing, I'm going to keep proceeding for now, but know that this meeting is being recorded and will be put up on YouTube later. So if you fall behind at all, you can feel free to go to the YouTube channel. When you go to the DC Prog Club meetings page, this meeting that you just signed into, there'll be a little YouTube icon. You can click on that to get to the video. Question?
When we make our GitHub account, can we use our personal email for that?
Yeah, you can use that if you want. That does bring up a good point though of if you do use your student account, you do get a free subscription to GitHub Premium Pro.
Yeah, GitHub Pro. And
Pro.
You actually don't have to sign up with your student email to get that. You just have to put it in. Like, it does it a bit more automatically if you use your student email.
Gotcha. So that's a nice little feature too. And yeah, we'll mention more about GitHub at the end there. But yeah, that's a good tool to use. One of the best, one perk of the many of having GitHub Premium is that you can have unlimited private repos. So that, if you have an assignment and stuff, like, you don't want that being public for everyone else to see, because that would not really be academically honest. So anyway, yeah, with that, we'll proceed on. So here's kind of the first steps we'll go through. I will get this started up. So first thing we'll do is we'll just make a new folder for our repo. So just a standard make directory command. And then what we want to do there is do a git init. And so what this does is it creates that initial repository or that folder. Yes, you should do that too. Forgot about that step. Good catch. Fun fact.
Increase the font size.
Yes.
You can see what you're typing.
That didn't work. Oh boy. Okay. 1 second. I got this. That doesn't work either, Nick.
Holding control and scrolling upward with that one.
Makes the whole thing. There we go. Okay. So, yes. So make your new repo, make your new folder, and then cd into that repo. You don't want to accidentally make an entire repository of your computer. I accidentally made a whole repository of my C drive one of the first days learning Git at Omnitech, and that was a fun experience because when you have that a repo on your C drive, every time a file changes, it sees it, and yeah, so don't accidentally do that. It's an easy fix if you do, but it's interesting. So once you get into that new folder, then you'll do that git init, which creates that new repository. And then once we, now that we have our repository made, we need to have some files in that repository in order to actually do the git stuff. So we'll just do a basic nano hello.txt. And in here we can just do a hello world. Save that. And then to check your status of your files in your repository, you run what's called git status. And what that does is it tells you, okay, here are your current files, that are either changed, are brand new, or if you've deleted files, it'll catch that too and say, hey, this file no longer exists. So this kind of just tells you where you're at currently in your working state. This is still in that modified state, compared to that modified staged and committed. This is that modified state. And so what we want to do now is we want to add hello text to our commit or stage it. And so to do that, we do a git add hello.txt. And then if you run a git status again, it'll show you that changes to be committed is a new file called hello.txt. So now that we're in the staged state, we're ready to commit or publish our change. So we'll do a git commit, and we need to do a flag m, and we need to include a message. So for this, we'll just say first commit. And it's important that you include a message on your commit. For example, if you forget to include a message, it'll say that, but that's something different. Live demos.
How do you get out of the text that you made?
Yes, so that's what I was going to try and demonstrate. So if you get stuck in a Vim thing, you do :Q, enter. They're in Nano. If you're in Nano, then it's Control X. And that should kick you out. If you don't include a git commit message, you'll get stuck in a Vim Vim window, which is confusing to get out of at first. Sorry, gotta configure this. Okay. So, trying that again. So this is what happens if you forget to include a git message. It wants you to include that message, so if you get in this spot, then you just put in what your commit message would have been if you remembered to put it there, and do first commit. And this put me in Nano after all. So we'll roll with that. So exit, and we do want to save it, and just hit enter, and then it will make that commit. If you remember to do the TACM first commit, you don't have to worry about that. It just commits it with that message. So do your best not to forget it, but if you do forget it, it's not the end of the world. And then to see your recent commits, you do git log, and that'll show you your recent commits, give you the hash for it, your message, and then who did it on what date. So,
Can you go back to the logging in stage? Because when I do the git commit, first commit, it still says, please tell me who you are.
yes. So, what that did was you need to configure your user email and your username. So in order to do that, you'll run this git config -- global command, and this configures your git globally across your machine. So you only have to run this once. And then you do user.email and whatever your email is here. And then it's very similar for the username. It's git config global -- global user.name, and then your name in those quotes. And so it should prompt you, like you said, where it has those examples there of what it wants from you. So if you just copy that and then just replace your name here or your email here with your name or email, that should help you to commit. Good question. Very good question. All right. So, one other part of Git is you can have multiple branches in a repository or multiple pointers to different commits. So, in order to switch to a different branch, you run a git checkout command. We do git checkout -b. That -b designates the creation of a new branch. So, for example, right now if I do git checkout -b new branch, it says a new branch is created titled new branch. If that branch is already existing, you just say git checkout and master, and it'll switch you back to master. But I want to be a new branch, so I'm going to do that. So Let me pull up my notes here. So when you create a new branch, like we did just now, off of an existing branch, it duplicates that existing branch completely. So right now, everything in new branch mirrors and is exactly the same as master. To prove that, I can do a git status, and it says nothing to commit, the working tree is clean, nothing's modified. However, when I change a file and commit it, then our branches will be at different spots. So for example, if we go back and do a nano hello.txt, and we change this to hi world, when we run that git status, we'll see once again that it's modified. So to do that, we will do a git add. So you can choose to git add each file manually, one at a time, but when you have like 20 files that are changed all at once, you obviously don't want to type each one out all at the same time. So if you're wanting to commit all of your changes, you can do a git add -A. That'll add all of those files and stage them. So we'll do a git status, and we'll see that that's staged, and a git commit. And we'll say we changed hello to hi. And there we can see that that our commit has worked, and that file has changed. And now you'll see that there's 2 commits on our new branch, where if we go and look at our master, there's still only that 1 commit. So they're now at 2 different places. Yeah. So that brings us into merging your branches. So what merging does is, like some pictures to exemplify. So say that the main tip was our master branch, and that the feature tip was our new branch. And so currently our master branch is right here, and our feature tip is 1 ahead. As you can see, we have 2 commits instead of 1. So what we want to do is combine those 2 commits to make 1 commit and catch master or main back up to our new branch, shown like this. So in order to do that, we need to first check out to the target branch that we want to go to. And the target branch is the branch that we want the changes to be merged into. So for this case, it would be master. So we want to check out, or let's see, git branch to see which one we're currently on. So we're already at master. So so we took care of that command already. So then what we want to do next is a git merge with source. And source is that branch containing the changes you want merged. So in this case, it's new branch. We want to pull the changes from new branch into our master branch. So we do a git merge new branch. And then if we do a git log on our master, you'll see that that now has 2 commits, just like new branch did. So a common thing that you may run into when you're collaborating with multiple people is what's called merge conflicts. And so that occurs whenever 2 people change the same line of code in 2 different ways. Git will see it and be like, I see that both lines are changed in 2 different spots, but I don't know which one you want me to keep. And so what happens there is you'll get notified of a merge conflict, and then you need to go back into your file, and it'll tell you like which line it's at and everything, and point you in that direction. And then you need to manually go and check, okay, which change do I want to keep? And once you're able to get all those merge conflicts resolved, you can continue with your merge, and then it should be able to pull in those changes. But when you're working alone, you should rarely ever see a merge conflict. But once you start working in teams, you can see it a little bit more if you guys are touching the same files. So some examples of remote repositories. And the difference between, or what a remote repository is, I should say, is kind of like it's like the example of saying, your local folders is your local repository, is what it's called. So your local repository would be like the files and folders on your computer itself. A remote repository would be like a Google Drive, a Dropbox, something up in the cloud per se. Those same files, but just up in the remote. And so some examples of remote repositories are GitHub, GitLab, Microsoft Azure, etc. GitHub's a pretty popular one. I used Azure this summer at my internship. And so both do the same thing and just a good, efficient way to back things up. And also that's how you are able to collaborate with others, is by, when everyone's on their own computer and they push up their changes, you'll go back to that GitHub or that Azure repo and pull those changes that others made so that you're back up to speed. So that kind of gets to our Git commands there. So git clone and then the URL. So that what that does is it takes that repository that's in the remote and it creates a local copy on your computer, and it's automatically set to track the remote repository. So it'll watch what's going on in the GitHub, and it'll compare it to your local computer and see, okay, is there anything that's changed in the GitHub that has not been installed on my computer yet? So that's when the Git Pull comes into play. Git Pull is a combination of Git Fetch and Git Merge. Git Fetch is what I said there, where it goes and checks to see what are the differences between GitHub and what's on my local computer. And Git Merge says, okay, take those changes and pull them in to my computer. So doing that Git Pull allows you to get those changes that other people have made. And Git Push is the opposite. Whenever you make a change and you want to publish it up to your GitHub, you use the Git Push command, and that takes the changes on your local computer that are not yet on the GitHub and pushes them up like so. Yeah. And so and like we said earlier, definitely encourage making a GitHub account, using those school credentials and getting that free premium or pro or whatever it is, and using that for your assignments and stuff like that. It's a good way to keep track of things. Just make sure that they're private, sort of thing. So yeah, with that, any questions? Seeing none, I will turn it over to none here.
Yeah, no.
Okay. What you have
Yeah.
planned for?
Next meeting. So this meeting was a bit information heavy, so we're gonna swing to the other side, over to the more recreational programming. We're gonna talk about programming competitions and how those work, and we're gonna do like a little mini programming competition. There may or may not be prizes. Don't hold me to that. Also, we are going to start having meetings, or the difficulty of the meetings is gonna eventually get a bit more difficult, and we are currently planning on doing essentially supplementary meetings that go over the more introductory topics a bit slower than we did here. So we don't have anything directly planned for that yet, but we are planning on it. So just so you know.
So if you had no idea what was going on throughout the entire presentation, don't feel like you don't belong or anything like that. Like, it's normal, and yeah, we got plans for something that's a little bit more beginner friendly, not a water, fire hydrant of information. And
Then also, if you feel like you already knew all this stuff, it'll get more interesting.
yes. So yeah, if you guys have any questions, about Git or just anything, afterwards now or even later, like a day or two later, like I said, our contact info is on the About page of dcprog.club. Feel free to reach out to us. We'd be more than happy to talk to you. Okay. Thanks for coming, and good to see a bunch of people here. So hope to see you again next week.